Hi, we're going to do the sample exam questions for Chapter 4, Chapter 5. There's a lot of them. 3 to the negative 4 equals 1 over 3 to the 4, which is 1 over 81. You can use your calculator on that. So this is negative of 1 over 3 to the 4. This negative just holds still. So there it is holding still. This negative makes it go in the denominator. So that's negative of 1 over 81. 3 to the 4th is just 81. This is the base. So the whole base goes in the denominator. So this is negative 3 raised to the 4, which when you do a negative raised to the 4, you're going to get a positive. So this is positive 1 over 81. This is a negative raised to the positive 4. So this is just 81. 3 to the 4th, I hope, is 81. I just took for granted that it was. I didn't even look on my calculator. I'll give it a calculator whirl just to make sure, and yes, it is. This is negative 3 raised to the 5th. So this negative just holds still, and then this is 3 to the 5th is 81 times 3, right? And so I don't know what 81 times 3 is, and that's 243. So negative 243. 3 raised to the 0 is 1. Anything raised to the 0 is 1. 0 raised to the 4 is 0. And this is 1 over negative 2 to the 3rd, which is, so using the negative exponent rule, which is negative 8, 1 over negative 8. And then I can write this negative out to the side. 1 over, whoops, I missed my negative sign. So just so you remember, back from chapter 1, they told us that if I had a fraction that had a negative in the numerator or in the denominator, that this was all the same, right? Writing it out to the side. And that's typically what they do. So if I have a over negative b, that's the same as negative a over b. And that's the same as negative a over b. So anyway, okay, then they just remind you about what it means to be simplified. And so they're saying, no parentheses and all those things. You can read those things. And they're just asking me to use the rules of exponents. So according to the rules of exponents, this is x to the 5th. You would add the exponents. According to the rules of exponents, you would subtract the exponents. So this is 2 minus 3, which is x to the negative 1. And then you're not allowed to write things with negative exponent. So this is 1 over x. And then this is 3 take away 2. Which is 3 take away 2, which is 1. So this is x to the 1, and you would just write x is what you would write. So we did a lovely job on those. This is a base to an exponent raised to an exponent, and according to the rules of exponents, that's multiply. That's x to the 6th. And so this is the product to a power rule. So this is 4 to the 3rd and x to the 2nd raised to the 3rd. 4 to the 3rd is 64. And x to the 2nd raised to the 3rd is x to the 6th. These all have base 4, so you add the exponents, you write the 4, and you add the exponents, 2 plus 3 plus 15, which is 4 raised to the 20. And that's 4 times 4 times 4 times 4 times 4, 20 times. That's a huge number. And it's not going to be under 1,000, so I'm just going to leave it as 4 raised to the 20 and not write it in this, because I would have to round, because that's gone into scientific notation. So this is the exact form. I have to leave it in exponential notation. Whereas 4 to the 3rd, I could write it in regular notation. It's just 64. When I add these exponents, I get x to the 1. I would probably use my negative exponent rule and write this as x to the 2nd and move this to the numerator, x to the 3rd, and then so the negative exponent rule says you can move it to the numerator if it's negative in the denominator, and this would be then x to the 5th. If you use the quotient rule, you would have gotten the same answer. So this was the negative exponent rule and the product rule, but if you would have used the quotient rule, you would have got x to the 2 minus negative 3. Minus of a negative is a plus, so that's 2 plus 3, x to the 5th. So either way, you would get the same answer. So whichever made you happy to do. And so my decision on what I think would be best here as well I can use the negative exponent rule first, or I could use the product to a power rule. I would probably use the product to a power rule and make an exponent 1 there, and then you multiply the exponents. So this is 4, and then 1 times negative 3 is negative 3, and x times 2 times negative 3 is negative 6. Then I would use the negative exponent rule. So this is 1 over 4 to the third and x to the sixth, since they were both negative. So that's 1 over 64 x to the sixth. And so that would be our answer there. And so same kind of idea here. I would probably use, I would think of, first of all, I'll tell you, a negative raised to an even power is equal to a positive, right? And that even power can be a negative. So if you have, I would raise all of these. I'd put a 1 here, and I would say this is a negative raised to the negative 4. This is 2. 1 times 4 is negative 4. Multiply, that's positive 12. And that's 8, right? Negative 8. And then a negative raised to any even power is a positive. So this is positive. So I don't need to write the sign. This is negative exponent, so it needs to go in the denominator. That needs to stay in the numerator. So when I get done here, this is x to the 12, and the denominator is 2 to the 4, and y to the 8. And it's going to go in the denominator. X to the 12th positive exponent, so it stays in the numerator. 2 to the 4th is 16, and so this is x to the 12th over 16 y to the 8th. And that would be a great way of doing it. There's other ways of doing it. This is dividing, and so this is 8 divided by negative 2 is negative 8 divided by negative 2 is 4. I think I'll just write my answers on here. I think I'm going to be able to do it. This is 7 take away 5 is 2, c to the second, and 3 take away negative 1. So if you wanted to, you could say with the d to the third over d to the negative 1, I'm thinking about this one, you could say it's d to the third, d to the 1, and when you put those together, it's d to the fourth. You could also use the quotient rule, which is 3 take away negative 1, 3 take away negative 1 on my d, which is also 4. Anyway, either way on your thought on that. Any base raised to the 0 is equal to 1. So this one, I'm going to have to use the power rule here. So this is x to the 6. This is x to the negative 15. And then I could use the product rule, and when I add those together, I get x to the negative 9. So 6 take away 15. 6 take away 15 is negative 9. I was just making sure. And so this is 1 over x to the 9. I got answer lines, and so I'm putting my stuff on the answer line now. Didn't have answer lines up there, so I was feeling like I needed to box my answers. X to the first is just x, right? And box my answers here. So I did it 2 ways and got the same answer. If you do something 2 ways and you get different answers, you need to choose one. Otherwise, you're going to make it wrong. You do the numbers together first at the front. So 3 times negative 10 is negative 30. And then x to the 7th, x to the 1. Oh, I missed a 1 right there. I'm going to write it because I was trying to be lazy. So 3 times negative 10 times negative 1. And then x to the 7, x to the 1, x to the 2, and y to the third, and y, right? And this is y to the 1. So here I have positive 30. I have, add those exponents is x to the 10, and y to the 4. And so there's my answer there. And this is another division one. And so when I start dividing here, this is negative 5. This is x to the second, quotient rule. This is x to y to the third, quotient rule. 1 take away 2 is z to the negative 1. This is a positive exponent, will stay in the numerator. This is positive exponent, will stay in the numerator. This is positive exponent, and will stay in the numerator. This has negative exponent, will go to the denominator. Everyone always says, hey, what about that negative? I thought that made it go to the denominator. It does not. It's not its exponent. Its exponent is 1. So if your exponent is positive, you stay where you're at. So this is going to be -5 in the top, x to the second, y to the third, and z to the 1, but you wouldn't have to write the 1 down there. You would just leave it as z. And so we did a lovely job on that. We're cruising right along. Scientific notation. So it's asking us to write this in scientific notation. So I need to move the decimal right there. So this is 3.14. And I moved it 1, 2, 3, 4, 5, 6 places. And because that's a really small number in regular notation, so in regular notation it's small, that means it's going to have a negative exponent when I write it in scientific notation. So this is times 10 to the -6. So this one is written in scientific notation. They would like me to write it in decimal notation or regular notation. And because it has negative exponent, I know that it's going to be really small number. So I'm going to move that exponent, and I'm going to move it one place, 2 places, 3 places, 4 places, 5 places. So that's where it's going to move, and I'm going to count to make sure. 1, 2, 3, 4, 5. I want you to notice I do not have 2 decimal points in this answer. I get this all the time, and people are then mad at me when I mark them wrong. Write this like this, and this is not right. Do not do that. Okay, so common boo-boo. So the decimal point is down here at the end. They're asking me to write it in scientific notation, so it's 3.14. So I moved it 1, 2, 3, 4 places. And because this was a big number in regular notation, I know that it's going to be a positive exponent when I write it in scientific notation. So times 10 to the, what did I say it was, 4? Should count them 1, 2, 3, 4 places again. So this is a big, this is 5. This is going to make a big number, so I'm going to move this decimal point. I wrote my decimal point instead of moving it, sorry. I'm going to erase better so it doesn't look like I have 2 decimal points in my answer. It's not right to have that. So I moved it 1, 2, 3, 4, 5, right? So let's see here. The decimal was here. 1, 2, 3, 4, 5. If you want to put in the commas, you can. 420,200 would be great. They're asking us to multiply these together and write our answer in scientific notation. I choose just to use my calculator to do that, and you can choose to do it by hand or use your calculator. I don't care. I'm going to put it with the times 10 here. I don't like that as well. I admit I forgot to put the parenthesis. I'm going to put it in. I don't like how it looks. I like how clean it is to put in on my calculator though. 1.092 times 10 to the -12. So all I had to do was know how to type it in, right? So this is a fraction. 5.46 times 10 to the 8, and 9.1 times 10 to the -5. So this is 6 times 10 to the 12th. Then this one, scientific notation. So fraction, parentheses, so I'm just typing it in, right? 5.4 times, did you guys see my scientific notation button right there? And so times 10 to the second, and parentheses 3.5, and then I hit this button right here at the bottom to the -9, and then end here. I know I don't like the way it looks on the screen either. 4.5, and then I'm going to hit the times 10 to the 6. Casio people, if you're out there, you have a great product, and there are a few things that you could fix on it, and if you call me, I'll tell you about them. You're so much better than some other companies. Won't mention them. 3.5 times 10 to the negative 16. Okay, so I did a lovely job on that. So this is asking me to evaluate, to do some substitution. So this is 3x to the second minus 2x times y. Negative 2 in for x, negative 2 in for x, 5 in for y. You can use your calculator after that. So this would be 3 and then parentheses negative 2 squared and then minus 2 times parentheses negative 2 times negative 5, positive 5. So that's 32. If you didn't put the parentheses, you got it wrong. And so I always tell people to put parentheses in. They're implied, and that's the reason, is because if you don't use them, you'll get it wrong. So the type of polynomial is, there's 3 types: monomial, binomial, trinomial. Because this has 3 terms, is a trinomial. The degree is the highest exponent. So this is x to the second, so that's degree 2. This is degree 0 on a constant, degree 4. Whatever's highest is the degree. So 4 is the degree. The type here is monomial. It's just a single term. And the degree is 0. And if it's just a constant, the degree is 0. The type here is binomial. I lost how to spell it when I was spelling it and then realized, oh, it's up there. Degree 5, degree 12. 12 is higher, so degree 12. Here it's asking me to subtract. And in order to subtract, you have to distribute the negative and then combine like terms. So 4x squared minus 2x minus 9. I'm going to distribute this negative. So that's minus 5x plus 6. Then you combine like terms. So this is negative 7. So this is 4x squared minus 7x. So I'm putting these together. And a negative 9 and a positive 6 is negative 9. Sorry, I was positive, negative, whatever I got. Negative 3, right? I don't know. I said everything but the right answer there. This one is long division because this is a binomial. So when it asks you to divide and you're dividing by a binomial, you have to use long division. So when you set it up, you have to make sure that it's in descending order. So this is in descending order. That's no problem. But this is not in descending order. So you want to write the leader first. 4x to the 4th is the leader. It's missing the x to the 3rd, so you want to fill it in with a placeholder 0. Minus 3x to the 2nd minus x minus 3. If you think that I'm doing the problems fast, you can pause the video. And so so that will really help you because it's a review, right? So I'm just wanting to show you how to do it. And I know you probably get some feedback that I went really fast, but gosh, there's a lot of problems and I'm really tired. So this is 2x to the 3rd. The next thing, so I'm going to put that right here, 2x to the 3rd. The next thing is to multiply. And when I go to multiply, I'm going to multiply this times this and this times this. So I'm going to get 4x to the 4th, and I'm going to get minus 6 x to the 3rd. Then when you multiply, you're multiplying 2x to the 3rd by 2x minus 3. I just want to write that so that everyone knows that's what we did, right? Then subtract. The subtract step it's really 3 steps. You have to put this, then you have to distribute what you just put there, and then you have to combine like terms. So that's the stories, right? So I have to put this, then I have to distribute the negative, then I have to combine like terms. This made 0, this made 6x to the 3rd minus 3x to the 2nd. I brought down, right? B, bring down. My cousin calls this the division family. Daddy, mommy, sister, brother. And so I think it's kind of a cute name for the division family. Then you start again with divide. And you're dividing the leader. 6x to the 3rd by 2x. And that gives me 3x to the 2nd, which I put right here, plus 3x to the 2nd. If it's minus, I put a minus. If it's positive, I put a plus. Then I multiply here. I get 6x to the 3rd minus 9x to the second. Then I do the subtract step, which is do the parentheses, distribute, and so I have to do this, put in your subtraction, distribute, and combine like terms. And it's the same darn algorithm every time. So here I get 6x to the second, and I'm going to bring down minus x. So I did all those steps, right? And it's the division I really kind of have to show myself. Otherwise, I feel like I'm kind of doing it on the paper here. So I'm dividing 6x to the second now by 2x. So that's going to give me 3x. So plus 3x. So I'm going to multiply that 6x to the second minus 9x. And then I do the subtract step, which means I put that, then I distribute, right? And then I combine like terms. So this is 8x minus 3 when I bring down. Then I do that algorithm again, right? Divide 8x by 2x, which is 4. So plus 4. So this is 8x minus 12. And then you do the subtract, then you distribute, and then you combine like terms. So my remainder is 9, right? 12 take away 3 is 9. So my answer is it going to fit on this line? 2x to the third plus 3x to the second plus 3x plus 4 plus 9 over 2x minus 3. Oh, I got kind of into my answer line. There, I tried to make it where it's separated so everyone know what I have. Dividing by a monomial is actually easier. You just have to divide the pieces. So this is 15x to the third. So this is a monomial. So I don't have to use long division, and I'm going to be smiling about that. So all I have to do is divide this by 5x, divide the next piece by 5x, and divide the next piece by 5x. So when I do 5 divided by 15 divided by 5 is 3, x to the, and then this is 3 take away 1 is 2. 5 divided by 5 is 1, x to the first, so minus x to the first, right? I don't have to write the 1. 10 divided by 5 is 2, minus 2, and the x's cancel out. So that's my answer there. So we did a lovely job on it. We're on 39. You can use the squaring formula, or you can just use FOIL. I would just use FOIL. Would be my preference. So I write it twice, and then I FOIL these together. That's 49x squared plus 21x, another 21x, and last but not least, plus 9. So they asked me to perform the indicated operation. The indicated operation was to multiply this or to square that. In order to square that, you can write it twice and multiply normally. Now I'm combining like terms there. And write your answer in descending order, it said. So I have my answer in descending order. So that's good. So I'm going to multiply this together. This is going to be 6 multiplies. I'm just happy that it's not more. People were telling me that on the lab I had one that had 9 multiplies. I know. And so 10x to the third and minus 6x to the second and plus 18x. And then on the inside, minus, and I'm going to stack them like a Wendy's double stack, minus 15x to the second plus 9x. 3 times 3 is 9, and I have negative there, and negative 27. So when I combine like terms, I have 10x to the third minus, I think that's 21x to the second plus 27, 18, 19, 20. Is that right? 18 and 9 is 27? Yeah, it is. All day long, right? So 27x and then minus 27. So yay, we got that one done. It's written in descending order, so I feel happy about that. This is add. So when you add, you just drop the parentheses and combine like terms. So I'm thinking to myself, 1/2, and then I have here So I'm dropping the parentheses. So I'm just going to cross them out because I'm tired and I don't want to have to write it again. You can tell I'm kind of grumpy too. Had kind of a hard day. So I'm going to have here minus 1/5, right? So that's what goes with the x to the thirds is 1/2 take away 1/5. And so I'm going to do that on my calculator. I don't want to do it by my hand, but I could do it by my hand because I can get a common denominator if I wanted to. And so, but it's my choice, right? 3/10. So this is 3/10 x to the third. I'm going to just write this down here and not write it right here. So that was my thoughts right here. Right? That was my thoughts. This is my x to the thirds. Oh, there's x to the fifths. I didn't see them. I'm going to scoot this over. 3, is there x to the fourths? There is. I'm going to have to scoot over a lot. I'm going to start again. I'm still crossing out these things. Okay, I should start with x to the fifths because they're the highest one. And so I have some x to the fifths right here. 4/5. Sorry. And minus 3/5. And I feel happy about that because I don't have to use my calculator. That's 1/5. Right? And so I won't have to worry. So this is 1/5 x to the fifth. So this is my thought about the x to the fifths. Then, so I got that. Then the x to the fourths, and I notice, oh, there isn't any except for this one. So plus 3/4 x to the fourth. Then my thoughts are on the x to the third. So I have 1/2 minus 1/5. And these are my thoughts, right, for the x to the third. So, and I think we already did that. It's still on my calculator screen, 3/10. It's positive, so plus 3/10 x to the third. So I just got these, right? I got the x to the fourth. I got the x to the fifth. That's here, minus 1/2 x to the second plus 2. So I got it in descending order. And I'm all done. So this has an add, and so, but it's got these divisions. And so if I could reduce this, that's what I would want to do. And I'm hoping that when after I reduce it, that it has a common denominator or that's whole number or something. I could make it where it has a common denominator, but then I would have to reduce after. And so it's just easier to reduce before. And it reduces really nicely because 40 divided by 8 is 5. X to the 10 divided by x to the second, you subtract the exponent. So you get 10 take away 2 is 8. Quotient rule. So this is y to the fifth plus 10 divided by 5 is 2. X to the 8, y to the fifth. These are like. If they weren't like, I wouldn't be able to add them together. But since they are like, I can. There wouldn't be anything wrong with it if I couldn't add them together. I would just say that's the answer. But since they're like, I can add them together. And so I did. Okay, 43. It's asking me to perform the indicated operation, which here is multiply. So I'm multiplying 5x times 3x is 15x squared. And I'm multiplying here. So that's 5 times half. So you can do it up here if you want, 5x times half. And you're really doing 5 over 1 times 1 over 2x. So if you wanted to, you could. So this is positive 5/2 x. So I did here and I did here. Now I'm going to do here and I'm going to get a negative. And I can do the same thing here as I did there. And do you guys agree that's going to be 3/2 x? And then last but not least, I'm going to have negative. A negative times a positive is a negative. And then I have 1/2 times 1/2, which is 1/4. So it had fractions in it, but I seem to be living. And 5 take away, it got common denominator, so that could be worse. 5 take away 3 is 2. So this is 2 over 2x, 2 over 2x, which is 1x, which is just x, right? So that's what I have in the middle. So I have 15x to the second plus x minus 1/4. So that's my answer there. Now I got 3 multiplies together. You can do any 2 that you want at a time. It doesn't matter. So I'm going to do the first 2. X times x is x squared. X times negative 4 is negative 4x. Minus 3x plus 12. And then I'm going to combine like terms before I go and do the next multiply. I can't talk. And if you wanted to reorder it so it's a binomial times a trinomial, you could. I'm going to just leave it the way it is. It doesn't matter to me. So this is x to the, I'm going to have 6 multiplies. X to the third minus 5x to the second. So I just did those 2. Now I'm going to do 7x. I'm going to distribute it. So that's negative 7x to the second. And then positive 35x. Then I'm going to do the 12, distribute it. So that's plus 12x minus 60. So when the dust clears, I get x to the third. These are like terms, minus 12x squared. Those are like terms, plus 47x minus 60. And did a good job on that. So it's asking me, this one's a little bit trickier than some that I've seen because of that minus right there. And so I'm still going to have to FOIL this, 6x plus 1 minus, and then I'm going to FOIL this, and I might as well FOIL that right now. What the heck? Yes, I'm not. Okay. Thank you. But if anyone's having ice cream, I'm in.
You want to read before?
Yeah, maybe a little bit. I'm going to FOIL this, but see how that negative needs to distribute. So after I FOIL it, the negative will have to distribute. So I'm going to get x times x is x squared. When it's a plus, I don't have to worry about it. Minus 5x plus 3x, and then minus 3 times negative 5 is negative 15. So I'm got that negative right there. So I'm just foiling this. So that's negative 15. Okay, I'm going to FOIL this while I'm here. So that's 36x to the second. Do you guys hear that? Root beer floats were proffered, or any other ice cream was proffered. Ah, that sounds good. So I'm going to go ahead and add these together right here. This is negative 2x. And I don't want to have to write the whole thing again just to distribute it. So this is going to be negative x squared. This is going to be plus 2x. This is going to be minus times a minus is a positive 15. And now I am going to combine like terms. So I have 36x squared, take away 1x squared, which is 35x squared. I have 6x plus 6x plus 2x, which is 12, 13, 14x. And I have 1 plus 15 is 16. And I have another long division problem to do. And it's also got missing term. I must have been wanting you to practice missing term. So 6x to the third plus 0 minus 14x minus 5. So we're doing our divide step. And the divide, we're dividing 6x to the third by 3x. So that gives us 2x to the second. And I'm going to put that right here. Then I'm going to multiply. So that's the algorithm, right? Divide, multiply. So now I'm going to multiply. So this is 6x to the third minus 2x to the second. And then I'm going to subtract, which means that you have to put this. Then you have to distribute that negative, then you have to combine like terms. So it's kind of a 3-step process. So here's me putting the negative. Oh, some aggression there on my lead of my pencil, right? So a negative times a positive is a negative. A negative times a negative is a positive. I'm going to combine now. This should be 0, and it is. 0 plus this is 2x squared minus 14x. And then I brought down, I don't know, I always do the bring down before I say I'm going to do it. And then I'm going to divide, and it's 2x to the second divided by 3x. a fraction. And I thought I didn't have any fractions in there. And but I certainly do. Well, my life will go on. So 2x, 2/3 x, so it is positive. So positive 2/3 x. I gotta check that problem. And when I multiply these together times this, right? When I multiply 2/3 times 3, and you can do it on your calculator, you get 2x to the second. When you multiply 2/3 times -1, you get negative 2/3 x. And I'm going to subtract. So distribute the negative. And I'm feeling like I need my calculator to do -14 plus 2/3. This is 0. Which is -40 over 3. And I'm going to bring down the 5, -5. And I'm going to divide the liters here. So my liter is -40 over 3, and I'm going to divide it by 3. And you can put that in your calculator if you need to. I didn't mean to have a fraction in there, so I must have got this problem out of your textbook or another textbook, and I try to not have fractions in there because we're just starting out. And so I didn't realize that. So I put it in there and I got -40 over 9. So I'm going to put that up here, -40 over 9. So then I'm going to multiply -40 over 9 times 3. And the good news is I know what it's going to equal. It's going to equal -40 over 3x. And you can test it to make sure that it does, right? -40 over 9 times 3. -40 over 3. And then I'm going to do here a -40 over 9 times the negative is a positive 40 over 9. And then I'm going to, I'm going to subtract and distribute the negative. And we're going to get this goes away, and we're going to get -5 minus 40 divided by 9 is -85 over 9. Oh my goodness. Okay, so this crazy answer, 2x to the second plus 2/3 x minus 40 over 9, and this is a negative, so plus, and then -85 over 9, that's my remainder, over 3x minus 1. So I don't see that I made a mistake on it, other than I think that I wouldn't have, I don't like the fractions there. That's not making me happy. Okay, so now it's on to factoring. And so it says factor completely or state that it's prime. So I think, oh, it's a trinomial. Does it have a greatest common factor? Well, it has 1 in common, which means do nothing. So since it's a trinomial, I unfoil x times x. The ways of making 8 are 1 times 8, but those don't subtract to give me 3 like I want. 1 and 8, right? Don't subtract to give me 3. And 2 and 4, and those don't subtract to give me 3. And I must have been in a mean mood because right here is a prime one, right? It doesn't factor, so this is prime. Because none of the combinations work to give the middle, right? They don't subtract to give the middle. This subtracts to give 2, that subtracts to give 7. No other ways of making 8. And so how about this one? So greatest common factor, it's trinomial. Greatest common factor is 1, so that means do nothing. And so make the first work, x times x, unfoil. Make the last work, And so I'm trying to think of things that multiply together to give 48, but when I add them, I get 19. And so 3 and 16 come to mind, because 3 times 16 is 48. And I want them both positive. This sign says they're the same, and I want them to make 19, so they're both going to be positive. And so when I multiply them, I get 48. When I add them, I get 19. So in order to make a positive, both of these have to be the same sign. So I'm going to have x plus 3, x plus 16. And you should look at it to see if it would factor any further. And anytime you have just x like that, it won't factor further because it won't have a difference. It won't be a difference of squares or a cubed. So just x, so I'm done. So I'm on looking at this one, and I'm like, greatest common factor is 1. It's a trinomial, and so the possibilities, it could be 2x and 2x to make 4x squared. It could be 1x and 4x. I'm not sure which one it is yet. And this is 1 and 1. And so whenever you have 1 in one of the positions, then you can just pay attention, in both positions here, you can just pay attention to these numbers here, because the 1s, when they multiply times 4 or by 1, leave them unchanged. When the 1s multiply by the 2s, leave them unchanged. So I want 5, so that's looking good for 5. This says the signs are the same, right? And this says I want negative, so both negative. So let's give a try to this. You have to, when it's something other than 1, x squared at the front, you have to put it together. So I'm thinking it's going to be x, 4x, and minus 1, minus 1. And I'm going to FOIL it together. That's my try, right? So when I multiply this together, I get 4x squared. When I multiply this together, I get minus 1x. When I multiply this together, I get minus 4x. There's the minus 5x that I was hoping for. And here I get positive 1. And so this is what I wanted. So my answer is x minus 1 times 4x minus 1. And this is done because it's only just x. If it was x to the second, it might factor further. And this is done because that's just x. If it was x to the second, it might factor further. It might not factor further too, but it doesn't have a chance of factoring further if it's just x. Then I'm looking at this, and it's a binomial. And so I say to myself, well, is there a greatest common factor? And this number is 25. And 25 doesn't divide evenly into 169, and if you don't believe me, you can do it on your calculator. 169 divided by 25, it doesn't go. The only thing that divides evenly into 25 is 5, besides 1. And everything, 1 goes into everything. Well, 5 doesn't go into 169 either. So the greatest common factor is 1. That means do nothing. And so I'm looking at this, and I'm thinking to myself, is it a difference of squares? So here I was thinking unfoil, right? And I didn't write. I said what I was thinking. I didn't write what I was thinking. So I'm thinking, yeah, it's a difference of squares, right? This is a perfect square. This is a minus, and that's a perfect square. So I'm thinking what squared minus what squared. And you don't have to write this line. You don't have to write that, right? I write it, and then people ask me, do I have to write that? I was just writing it to show you what I was doing, but no, you don't have to write it. And so 169 is 13 squared. I'm going to make sure, I'm going to verify that it's 13 squared, just because I thought it was. Whoops, I clicked two things at the same time. 13 squared, it's like hot diggity dog. If you didn't even know what it was, then you could use the square root feature on your calculator. And if it came out nicely, then you know it's a perfect square. So the mnemonic device is add the bases. 5x plus 13, 5x minus 13. That's the mnemonic device. Add them and subtract them. It's a binomial times a binomial when you have a difference of squares. This is done because it's just x. This is done because it's just x. There wasn't a greatest common factor, so I'm all happy. So I'm now looking at 51, and I'm like, oh, greatest common factor is 1. It's a binomial. It's a difference of squares, right? So it's, I can see that it's a difference of squares. So it's what squared minus what squared. I usually just think this, but it's a good idea to write it if you want. And so the mnemonic device is add the bases, 2x plus 1, 2x minus 1, and then we're done. On this one, though, it has a greatest common factor. And so I'm thinking, what is the greatest common factor? I can see that 5 goes into both of those. 45 doesn't go into 80. And I don't think 45 is 5 times 9, and 9 doesn't go into 80, and 3 doesn't go into 80. So I think it's just 5x to the second. So you put it out in the front, 5x to the second. And 5 goes into 80 16 times, is that right? So I'm dividing it. 80 divided by 5 is 16, and I was right. So 16x to the second minus 9. And the monomial you're done with. So it goes right here. But this binomial, if it factors further, then you should factor it further. And I notice, oh, well, it's a difference of squares, right? So what squared minus what squared? So this is 4x, and this is 3. So you add the bases for x plus 3, and you subtract the bases for x minus 3. And then you're done because it's just x. So the monomials are done. Then this one's 53, and I can count the terms, and it's got 4 terms. When it has 4 terms, you still look at the greatest common factor, and the greatest common factor here is 1 because I have a 1 here. And I think it makes it better if you write it in descending order. And sometimes it's not possible if you don't write it in a different order than what it was in. And so descending order, it will always work. So I'm going to use descending order. So it has a, you group the first two, right? With 4 terms, you try grouping. So x squared, x plus 1, bring down the sign, plus, greatest common factor 5, and then x plus 1. If the binomials are not the same, you've messed up, but they are the same. So x plus 1, so you pull it to the front, and you get x squared plus 5. And I'm done because it's just x to the first. This is x to the second, but it's not a difference of squares because that's not a minus, and 5's not a perfect square. So, and it's not a cube. So we're just done with it, even though it had a square in it. Had this been minus 4, then it would have been a difference of squares, and we could have factored it. So I noticed this one, I'm like, oh man, it's all out of order, right? It's a trinomial and it's all out of order. So I'm going to write it in order. Minus 3x to the third plus 15x to the second plus 42x. And then I'm thinking about the greatest common factor. And I know that the leader is negative, so I know that I'm going to factor out a negative on the greatest common factor. And they actually have 3 in common. 3 goes into 15 and 3 goes into 42 rather. I said 52, and I got the I by one of my family members because they were like, I don't think 3 goes into 52. And then x. So the greatest common factor is 3x, so I'm going to put it in the front. And then when I factor it out, I'm going to get a positive here, x squared. So when I multiply this together, a negative times a positive is a negative. 3 and 1 and 2 more make 3, okay? And then a negative times a negative makes a positive, 5x. 3 times 5 is 15, x times x is x squared. A negative times a negative is a positive, and 42 divided by 3 is 14, so this is 14. The monomial's done, and I'm going to put it on the don't forget me line, right? It's my answer line, and then I'm going to ignore it. And then this is still a trinomial, and on a trinomial, you use unfoil, right? So I'm going to try to unfoil it, x times x, and so I'm thinking of things that multiply together to give 14, like 2 and 7, and I want it to be negative, so this means one of them has to be positive and one of them has to be negative to make a result that's negative. I want the bigger one to be negative because I want, when I add them together, when I combine them, I want to get negative 5. So when I multiply them, I want to get negative 14. When I combine them, I want to get negative 5. So I'm like, hot diggity dog. I didn't have to worry about these numbers up here because they were 1. And so that was like nice too. And so this is x plus 2. X minus 7. And of course, all of these factoring problems that I've done, every single one of them, I can check my work by foiling it back together to make sure that it equals what I started with. But I have so many problems to do and so many other things to do after them that I'm not checking them. But you can check them and you can tell me if I got one wrong, and I will shoot a new video and fix it. So this is a binomial, and I see that it has a greatest common factor of 5. So I'm going to factor out the 5. So this is x cubed, and I don't know what 320 divided by 5 is. It's 64, so plus 64. So the 5 is done, and I put it on the don't forget me line. And this is not, it was a binomial, but that's not a difference of squares. Because in order to be a difference of squares, this has to be x to the second. But it's not, it's x to the third. That tells me, because it's x to the third, that it's likely a cube. So in order to be a cube, this has to be a perfect cube, x to the third is a perfect cube. And this has to be a perfect cubed, and 64 is a perfect cubed, it's 4 to the third. So you want to write so that you can see the bases. So what to the third plus what to the third, and this is x and this is 4. And you do finger over 3's, write what you see. It's a formula. It's a binomial times a trinomial. So this is x plus 4. Then you square, and what do you square? You square x, so you get x squared, and you put it right there. Then you multiply. What do you multiply? These two bases, x times 4, and you put it right here, 4x. And then you square. What do you square? You square the 4, and you put the answer right here, 16. And then it ends, the song ends abruptly, soap. Same as I started with, which was positive. Opposite of that, always positive. And then this binomial is all done, monomials are done, and this trinomial is always prime. It won't work. So we did a lovely job on that. I'm looking at this one and I'm trying to think, okay, it's a trinomial. Does it have a greatest common factor? So I can see that 4 is the smallest number, and 4 doesn't go evenly into 5. And the things that divide evenly into 4, like 2, don't go into 5 either. So the greatest common factor is 1. So I'm going to unfoil. And so the possibilities, this is the one where I have to check it. It's the only one that I really kind of have to check, because I'm kind of using trial and error. I'm saying this is a possibility for it to factor, does it? And 2 and 2. And I know the signs are 1 positive and 1 negative to make a negative, but I don't know which one's which. So you go with your gut feeling of what it would be. And so do you think it's 2x and 3x or 1x and 6x? Whatever you think it is, that's what you go with. I'm going to go with my gut feeling. I think it's 2x and 3x. I don't know if it is or not. And then the 1 and the 4, I can't put the 4 in here because that would have a greatest common factor with the 2. So I can put the 4 over here and the 1 here. And then when I do the outer, that's going to make 8x, and I know I don't have the sign on it yet, and that's going to make 3x on the inner. And I'm like, oh, good, because I knew that when this was a subtract, that you would subtract to get the middle, and that's because the signs are going to be 1 positive and 1 negative, so you'll subtract it when you combine them. And look, that's going to make 5. So I need this 8 to be negative, so I get negative 5. So that means that this has to be negative, and this has to be positive. And then you could foil the whole thing together to make sure that it works. But I'm like convinced on the smiley face, frowny face that it worked. So my answer is, and I got lucky on the first try. If you practice, you get, I don't know, you get a good gut feeling. I don't know why, of that. And sometimes I get it on the second try, but a lot of times I can't help but get it on the first try. And just because your number sense gets so good. So do these have something in common for all 4 terms? Because that's what you would be thinking. And the smallest number is 2, and 2 doesn't go evenly into 75 or 3, and 1 goes into 2, but 1 goes into everything. They don't all have an x. So the greatest common factor is 1. So that means you don't have to do anything special. But since this has got 4 terms, you use grouping. You want to make sure that it's in descending order, and it already is in descending order. So those have x squared in common. So this is 3x minus 2. You bring down that sign because my leader is negative, and then you're going to factor out the greatest common factor, but it should be negative. Is it 25? Because 50 doesn't go into 75, but 25 does, right? So this is 25. So this is negative 25 times positive 3x to make negative 75. And a negative times a negative to make a positive. And then 25 times 2 is 50. If these aren't the same, they're the same, right? If not, go fix your mistake. And then continue on when they are the same. So if they are the same, then you factor it out to the front, 3x minus 2, and then you can put your finger over it, and it's x squared minus 25. And I hope that you're recognizing x squared minus 25 as a DOS. It's a difference of squares, right? And so when I factor it, I'm thinking x squared minus 5 squared. You add the bases, you subtract the bases, so we still should have 3x minus 2. So when we add the bases, x plus 5, x minus 5, and then we're all done. So factoring it completely means sometimes you have more work to do after you're done. When you just have x, you're done on a binomial. So I have just x there, so I'm done. This one has, it looks like it's going to have a greatest common factor. It's a binomial, and it looks like the greatest common factor, let's see, 24 probably doesn't go evenly into 54, my guess. And I checked it with my calculator, and it doesn't. But I think that 6 goes into both of them, right? And so I'm thinking 6. And then they have x in common, but they don't have y in common. So 6x, so this is going to be 4x to the second minus 9y to the second. So I factored out the greatest common factor, and I'm going to put the 6x on the don't forget me line, and I'm looking at this binomial. Remember binomials, greatest common factor. Is it somebody for me? No. Oh, okay. It can be a greatest common factor. They can be a difference of squares. This one's a difference of squares, right? Because 4 is a perfect square, x squared is a perfect square. It's a minus. 9 is perfect square, y squared. So I'm thinking what squared minus what squared. So this is 2x and 3y. So you add the bases, 2x plus 3y, and you subtract the bases, 2x minus 3y, and then I'm done. So I did a lovely job on that one, and I could multiply it all back together and make sure that it worked. And haven't seen a lot of cubes in this, just maybe 2, right? And so maybe there should be more. So now it's on solve. So this one's already factored, got 0 on one side, so that's really nice of them. This doesn't have a variable in it, and 8 doesn't equal 0, so that's not going to give you any answer. But x plus 30, it has a variable in it, so I'm going to get, when I take away 30 both sides, I'm going to get x is negative 30 for one of my answers. And the other answer, or, is x minus 35 equals 0, so I'm going to add 35. And I'm going to get x equals 35 as the other answer. So different from 59 was here I have a variable 2x. So I'm saying, when does 2x equal 0? Well, because it has a variable, I can solve it. Divide by 2, divide by 2, x, 0 divided by 2 is 0. So x is 0 is one of my solutions. Or, and then x plus 3 equals 0 is a solution. So I'm going to take away 3, take away 3. X is negative 3. So that's one of my solutions as well. Negative 3. And then 2x minus 5 is a third solution. So I'm going to add 5. So I get 2x equals 5. And then divide by 2, divide by 2. Or another answer, x equals 5 over 2. And I'm going to make a line there so that it doesn't look like that was getting into my answer field there. So I did a lovely job on that. There were 3 answers, right? So we did wonderful. So if you factored and you have a greatest common factor and it had a variable in it, then you'll have 3 answers. And this was before they factored it for me, somebody factored it for me and was really nice to me. I didn't have to factor it myself. It was x to the third. So if you multiply that together, it's x to the third, and that's why we got 3 solutions. Where if you multiply this together, it'll only be x to the second, and that's why we got 2 solutions. So this is x to the second, so I'm expecting 2 solutions. I already have 0 on one side, so I'm like hot diggity dog, and it's a binomial. And a binomial, I think, is easier to factor than a trinomial. That's me personally. Binomials start off with greatest common factor, just like everything does. And this does have a greatest common factor of x. So this is x times x minus 4 equals 0. Then you set the pieces equal to 0. So x equals 0, not much to solve there. That's one of the solutions. And then the other solution, x minus 4 equals 0. And this is not a lot to solve. Add 4. More than the other one though, right? The other one, just that was the answer. So those are the 2 answers. It was degree 2, so I have 2 answers. This one is a binomial, and I got 0 on one side already. And that's good news for me because binomials are easier to factor. They're either greatest common factor, which this one is not, or it has greatest common factor of 1, or they're a difference of squares, which this one is. So this is x squared minus 7 squared, right? So this is x plus 7, x minus 7 equals 0. And then you set the pieces equal to 0. So x plus 7 equals 0 is going to give me, when I take away 7 from both sides, I'm going to get x equals negative 7 from one of my answers, and then x minus 7 equals 0. I'm going to get 7 from one of my answers. So x equals 7. I did quite a lovely job on that. This one is degree 2. And so when it's degree 2 is when you want to get 0 on one side. And so this is degree 2, degree 1, degree 0. The highest is degree 2, so you want to get 0 on one side. And I want my leader to be positive. So I'm going to take away 27 from both sides. And this is last. So this guy goes first. This guy goes second. This guy goes last. There's a hierarchy. Now I got to factor it. And I'm like grateful this is just x times x. 27. See, I want it to subtract to be 6. So I want it to multiply together to give negative 7. But when I subtract the numbers, one's going to be positive, one's going to be negative. So that's why you're going to subtract. I want to get 6. So I'm trying to think. Would it be 3 and 9? And the bigger one is negative. So this is x plus 3, x minus 9 equals 0. And then you're going to x plus 3 equals 0. So that's take away 3 from both sides. You get where you can skip that step. You get where you're really good at it. X minus 9 equals 0. I kind of wrote it off here. So I'm going to add 9, right? So x equals 9. And truly this is OR. So these are my 2 answers. And yes, you do have to give both answers. I expected 2 answers because it was degree 2. So this one is, it's already got 0 on one side. It's degree 2, so you want 0 on one side. I noticed that it has a common factor of 3. So I'm going to pull out the greatest common factor. You always think about the greatest common factor every problem, every time when you have to factor. So it has a 3 in common. So this is x squared plus 5x minus, and I've done 42 divided by 3 on the calculator twice today. Twice in this video actually. So 14, so you'd think I would remember it. So I'm trying to think of things that multiply together to give 14, but when I subtract them, I get 5. And so I think it's 2 and 7. 5 is bigger, so the 7 is positive. 5 is positive, so the 7, because it's bigger, is positive. That's what I was trying to say. So this is going to be x, this is x times x, right? Make the first work, make the last work. X minus 2, x plus 7, and here's the 3 there, equals 0. Now, 3 doesn't have a variable in it, and 3 is never equal to 0. So this is not going to give an answer to it. And x minus 2 equals 0 is going to give the answer of 2. So one answer is 2, and the other answer is going to be -7, right? So x equals -7. Again, I expected 2 answers. So if I came down here and noticed I had 3 answers, I'd say to myself, what have I done? I've gotten crazy here. And so just because it's a term out here in front doesn't mean that it's an answer. It has to have a variable in it. So if it's just a constant like 3, that drives people crazy. They feel like I'm ignoring the 3, and I am. And so the 3 will have to deal with it. Unfortunately, they got it factored, but they don't have 0 on one side. So what we're going to have to do is we're going to have to multiply the gosh darn thing together, x squared, so that we can get 0 on one side, and then factor it. So that's what we're doing. So I want 0 on one side, so I'm going to take away 7, and it goes last here. So when the dust clears here, I get x squared. This is plus 2x. This is minus 15 equals 0. And I'm like, okay, I can factor this guy. This is x times x, and this is 5 times 3. And I want this to subtract to give 2. And so the 5 is bigger, so this is going to be x plus 5, x minus 3. Equals 0. So x plus 5 equals 0. I'm going to take away 5. I get x equals minus 5 for one of my answers. And my other answer, x minus 3 equals 0. Add 3, add 3. I'm going to get x equals 3 for the other answer. This is one of my favorite problems, and I almost always have a problem like it on the test. On one zip line in a canopy tour, canopy top the trees. I don't know why I can't say that right now. I'm really tired though. That might be why. In Costa Rica, riders drop 58 feet while covering a distance of 840 feet along the ground. How long is the zip line? So this is what a zip line looks like. It is a line that goes like this on a slant to the ground, and then it's anchored at the ground. I don't know why I drew it so big, right? But there has to be some kind of a platform. And so that people climb up there on. And so, so this is the platform here. And that's the actual, this is the zip line. And that's what they're asking you. Here's the zip line. This is what they're asking me. How long is this, right? And they're telling me that the drop, if you were at the top and you just went straight down, the drop is 58 feet. And if your mother ran along the bottom, along the ground, filming you as you did the zip line, she would run 840 feet. And so there's a right angle right here. And so this is the Pythagorean Theorem. And I don't know if you guys remember the Pythagorean Theorem. That was one of our stories for this time. There's my right angle, A and B and C. And we know that A squared plus B squared equals C squared. So in my case, it's 58 squared plus 840 squared equals, and then you call the zip line length whatever you want. I'm going to call it C squared. And so 58 squared plus 840 squared, right? So I put that in my calculator, is this huge freaking number here. And how they've showed me to solve things that are quadratic, degree 2, right, is to get 0 on one side. So I have C squared, and I'm going to get 0 on one side. And so I'm going to take away, because it's happy and positive over there, take away this huge number right here. And then what I have to do is I have to factor this thing. So I get 0 equals C squared minus 708,964. And doesn't have a greatest common factor other than 1. So I'm saying to myself, does this binomial, is it a difference of squares? So I'm thinking that it will be a difference of squares, and I'm going to give it a try. 70 with my calculator. It's not one I recognize. So I'm not saying to myself, oh, I think it's a difference of squares, but I see that it went evenly, right? So this is c squared minus 842 squared. So I told you they had in your book, this is actually a problem out of the homework, ones that come out quite big numbers. So this is c plus 842 times c minus 842 equals 0. So c plus 842 equals 0. And I'm going to take away 842 both sides. So I get c equals 842 minus 842, right? And that's not negative, so that's not right. And then c minus 842 equals 0. You're going to add it to both sides. Yes, there's another way that you can do it. This is the way that they have showed us to solve it in the book. And so, and if you already have learned that other way, you can use it. 842 feet. I find that when I try to show people things that are not in the book, it just confuses them. So I just try to do it the way the book does it. We are going to do that other method in chapter, I'm not really remembering right now. Maybe it's chapter 10. It might be 9. I'm not sure. It doesn't matter. Chapter in the future. Okay, one more last problem. If a rocket is fired vertically into the air with a speed of 240 feet per second, its height in feet at a time t seconds is given by this formula. So I actually just need to use this formula, not come up with a formula to use. Why are you doing that, Mr.? Are you tired? At what times will the rocket be 700 feet above the ground? So when they talk about this right here, the formula they gave me was h equals negative 16t squared plus 240t. And so when they gave me that, they told me what h stood for. H stood for height, right, above the ground. And t stood for time. And the time was in seconds. And in fact, they told you that the height would be in feet somewhere right here. The height is in feet. So this is the height in feet. So when they start talking about 704 feet, I know that they're talking about the height, right? And so I'm going to put in here height is 704 right there equals negative 16. And they asked me when is this going to happen? And that means find the time, right? And that's what T stands for, so hot diggity dog. So this time I notice that my lead term is negative. It is quadratic, t to the second, t to the 0, right? T to the first. So it's degree 2. So you want to get 0 on one side, and you want your leader to be positive. So I'm going to add 16t squared to that side over here. I'm going to put it first because it's the leader, so it goes first. And I'm going to subtract 240t. So subtract 240t. I'm going to put that in the middle. So when the dust clears here, I'm going to have 16t squared minus 240t plus 704 equals 0. And then I want to see, does it have a common factor? So I want to know, does 16 go evenly into 240? And I don't know if it does or not. If it does, great. And if it doesn't, great. Whatever. I'll deal with it. It does. Does it go evenly into 704? And if it does, I'm going to be jazzed. And it does. So I'm pretty happy about that. I don't remember how many times though, so I'm going to have to go back. But I know 16 went into each one of these. So I'm going to do 240 divided by 16 again. And that was 15. So this is minus 15t. And then I'm going to do the 704 divided by 16 again, which was 44. So the 16 I'm ignoring, but I'm factoring this t times t, and I'm like grateful that it's the easier type to factor and didn't have a, and so let's see, 4 and 11 make 44, right? And so, and they're both negative. And so when I multiply them together, I get, they're the same sign because it's positive. A negative times a negative is a positive. When I combine these, I get 15. So this is t minus 4, t minus 11, equals 0. So 16 doesn't equal 0 ever. So you just ignore that. So I'm going to write this over here so I'm running out of room. 16 doesn't equal 0. Not t minus 4 equals 0 when t is add 4 to both sides when t is 4. T minus 11 equals 0 when you add 11 to both sides, t is 11. So this is after 4 seconds. Remember, time was in seconds, right? Time was in seconds. So after 4 seconds, the rocket is 704 feet off the ground, and also at 11 seconds. If you're wondering, how could it be that it was 2 times? Well, this is what happened with the rocket, right? I'll draw the rocket right here. So there's my rocket, and my rocket goes up, and at 4 seconds, so this is after 4 seconds, it's here at 704 feet. And it continues to go up, and then the rocket loses, you know, as it goes up, gravity's working on it, it's pulling it back to the earth, right? And then it finally loses all of its velocity becomes 0, and it turns around and it comes back down. And when it comes back down, it once again hits that spot at 11 seconds. It becomes at 704 feet again. And in fact, all of the distances, all of the heights would happen twice, right? And so, except for the very highest would only happen once, but all of the others would happen twice. And so anyway, so that's the story there, and we did a lovely job. How long did it take me? Oh my gosh, goodness gracious, long.